Hi guys, welcome to today's video. So today we'll be dealing with dynamics in N2 on how we can approach different types of questions when we are calculating the total displacement, when we are calculating acceleration, when we are calculating time, and when we are calculating deceleration. Right, so now let's look at this practical example that we are going to be doing. Right, so now we are given a table, right? In this table we have time and we have velocity, right? Now the first question says that make a sketch of the velocity time graph. So we are asked to draw the velocity time graph. So the first thing that you are going to do, you are just going to draw the vertical axis, right, and the horizontal axis. Now this may not be nice, but yours must be very nice, right? So it's starting from 0. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah. So this is going to be our time, right, in seconds. And then on the velocity type, right, the velocity side, I mean. So let's look at our velocity. It's starting from 0 to 5. So it means that we can start our points from 0 and say 1, 2, 3, 4, and 5. This is the velocity, right? And it's in meters per second. Awesome. So now let's look at our table, right? So at 0 seconds, what's going on in velocity? It's also 0. So it's right here. Did not change. But then from 0 to 2 seconds, right, the velocity increased, right, from 0 to 5 meters per second. So now this means that we are going to draw it right here, right? Going to draw it right here. That's the first line. So from 0 to 2 seconds, the acceleration increased to 5 meters per second. So now what's going on after 2 seconds? So now on 7 seconds, the velocity remained constant. As you can see, it did not change, right? So now this means that from here, it did not change. The velocity remained constant. The velocity remained constant. So now what's going on after 7 seconds? After 7 seconds, right, it reached to 11 seconds, whereby now the velocity is 0. So now by looking at this, do you see that the velocity decreased from 5 meters per second to 0? So now this means that from this point we have deceleration, right? So we have deceleration. The car slowed down until it reached 0 meters per second. So now this is your velocity time graph. All right, so now let's look at the next question. The next question says that calculate the total displacement of the car over 11 seconds. So now when it comes to dynamics in N2 and you are asked to calculate the total displacement using your graph, right? What you are always going to be doing, you are going to divide the graph in shapes, right? That's basically how you can calculate your total displacement. So we have 3 shapes on this one. We have 1, 2, and 3. So we have a triangle, rectangle, and a triangle again, right? So now we are asked to calculate the total displacement, right? So this is number 1, right? So number 2, total displacement, right? Now this is a triangle, so it's a half BH plus BH plus a half of BH, right? Which is equal to a half of 5 times. So from here to here is 2 seconds. So we are going to say 2 seconds plus BH is 5 times. So now we need to know what's the time between these, right? So we are going to say 7 minus 2 seconds. So that's going to give you 5 seconds plus a half again. So it's going to be 5 times, right? So again, we need to know what's the acceleration from mean time. Sorry, we need to know the time from this point to this point. So it's going to be 11 minus 7. So that's going to be 4. Now you can punch the values onto your calculator. That's going to give you 40 meters. Right, so now you have calculated your total displacement of the car over 11 seconds. So now the next question says that calculate the deceleration of the car from 7 to 11 seconds, right? So now we need to know what's the deceleration of the car. So now we need to, what's the initial velocity, right? Our initial velocity, it's 5, right? Because it started to decelerate from 5 meters per second straight to 0. So now this means that our final velocity, it's 0, right? So now this means that we have A is equals to V minus U divided by time. Another thing, we need to know what's the time, right? What's the time? What's the total time actually that it took the car to decelerate from 5 to 0 meters per second? So you're going to say 11 minus 7, which is going to give you 5 seconds, right? So we do have our time, which is 4 seconds. So now we can calculate what our deceleration is. The final velocity, it's 0. 0 minus 5 divided by 4, that's going to give you a negative 1,25 meters per second squared. So that's basically how you can calculate your deceleration. Make sure that you find the time, right, between the deceleration from, okay, the first thing that we needed, right, was for us to find the time of deceleration from 5 meters per second to 0 meters per second. So that's why we subtracted this. So it's 11 minus 7. So this is how you are going to calculate. This is how you're going to approach your questions in terms of dynamics in N2. So now let us look at another question, right? Now looking at the second one, they're saying that a truck is brought to rest, right, from a velocity of 80 kilometers per hour over a distance of 50 meters. Right, so now let's try to make a sketch. So we have a truck. Okay, this is not really good, but this is our truck. I've never seen such a truck also, but let's just say it's a truck, right? So now they're saying that it's brought to rest. So now we know that the final velocity is 0 meters per second, right? Our initial velocity is 80 kilometers per hour, right? So that's the initial velocity. The displacement, they say that it's 50 meters, right? Sorry, it's 50 meters, right? So now we do have everything, but we have a slight problem, right? The initial velocity is in kilometers per hour, and we need the initial velocity to be in meters per hour. So what we are going to do, when you are converting from kilometers per hour to meters per hour, you are always going to be dividing by 3,6. So now this means that we are going to divide this value by 3,6, which is going to give you 22,22 meters per second. Right, so now we have everything sorted out. So now what's the first question? The first question says that calculate the deceleration, right? So we need to know what's the deceleration of the truck, right? Okay, so we have the final velocity, we have the initial velocity of displacement, we have we're looking for the deceleration. So we can use this formula, v squared, it's equal to v initial squared plus plus 2a s, right? So now since we're looking for the acceleration, right, and we do have everything, so we can substitute 0 squared, it's equal to 22,222 squared plus 2 times the acceleration times 50, right? So now we can bring this to the left hand side, the sign changes, so now it becomes negative 22,222 and 2 squared, it's equal to 100a. Divide both sides by 100, so that's going to give you a, it's equal to negative 4,938 meters per second squared. So that's your deceleration of the truck, right? So now when it comes to calculating acceleration, calculating the time, you are going to use the equations of motion. So these are the equations of motion. Initial squared plus 8, sorry, it's 2as. Vf is equal to v initial plus 80. S is equal to v initial times time plus a half of a t squared, right? So these are the equations that you are going to use. So now this one, let me write this one properly so that you can see it. V initial squared plus 2as, right? So these are the equations of motions that you can use, right? So like, in order for you to actually make things easy for yourself, I'd really recommend that you write the data before you actually calculate anything. Write down the data, right? That's the first important thing. Write down the data. Number two, if there's anything that you need to convert it. And then the last part, you are going to check for an equation that corresponds with your given data. If it corresponds, then you are going to use that equation, right? So now let's look at number two. Now let's just say this is an example, right? Now writing your data, right? So in number two, they're saying that calculate the time taken for the deceleration of the truck, right? So we're looking for what? The deceleration, right? Okay, sorry, we're looking for, let's say, the time taken for deceleration, right? We do have our acceleration, right, which is negative 4,938 meters per second, right? And then what else do we have? We have the initial velocity, which is 22,222 meters per second. This is squared. We have the final velocity, right? It's 0 meters per second, and we're looking for the time. Now let's come back here and check which equation can we use. Okay, let's look at this one. Do we have the final velocity? Yes, we do. Do we have the initial velocity? Yes, we do. We have the acceleration? Yes, we do. Do we have displacement? Yes, we do. So this equation, it's useless to us. We can't use it, right? Now let's look at the second one. Do we have the final velocity? Yes, we do. Do we have the initial? Of course. We're looking for what? We do have the acceleration, but we're looking for the time. So we can use this equation, right? So now this means that it's going to be Vf, it's equal to V initial plus AT, right? So it's 0, 22,222 plus, right, negative 4,938 time. So we bring this to the left hand side, therefore the sign changes. Now it becomes negative 22,22. It's equal to negative 4,938, right? Divide both sides by negative 4,938. 4,938. These are going to cancel out. So now if you can punch this on your calculator, it's going to give you 4,5 seconds. So this is basically how you can calculate velocity, how you can calculate time, how you can calculate the total displacement. So remember that when we are calculating the total displacement, right, from the graph, you are going to use the shape of the graph. So you will either get a rectangle or a triangle, or there's a lot of things that you can get depending on the motion of the object or the car or whatsoever that they are using in that particular question. Right, so now thank you for watching the video. Please do like and subscribe to my channel to stay updated when I upload new content.